Hey guys, welcome to Machine Learning with me. In the previous videos, we learned linear regression and multiple linear regression and implemented them step by step. Now it's time to understand how models actually learn internally.
We've seen these models make predictions, right? But have you ever wondered how they get better? How does a machine go from making, pretty wild guesses to giving us really accurate results? This explainer is all about pulling back the curtain and seeing exactly how a model learns and improves itself from the inside out.
And the answer to that big question, it all comes down to one really powerful and fundamental algorithm. It's the core engine that drives the learning process in so many models. And we're talking about gradient descent.
So what is it really? Well, to put it simply, gradient descent is what we call an optimization algorithm. Just think of it as a process the model uses to methodically find the best possible internal settings, or parameters. For those linear regression models we looked at, these parameters are just the slope and the intercept of our line. Gradient descent is absolutely obsessed with tweaking these parameters to minimize one thing: error.
See, whenever a model is training, it really only has two simple goals. First, to make fewer mistakes. That's what we mean by reducing the error. And second, to get better at predicting the correct answers, or, improving its accuracy. Gradient descent is the very technique that makes this whole cycle of improvement possible.
Now, I know this might sound a little abstract, so instead of jumping into a bunch of heavy math right away, we're going to use a simple visual metaphor. This should help you build a really strong intuition for how this all works. Let's use what we call the hill analogy.
Okay, I want you to just picture this for a second. Imagine you're standing somewhere on a big, grassy, rolling hill. It's a bit foggy, so you can only really see the ground right around your feet.
So in this analogy, the entire hill represents the total error of our model. This means if you're standing way up high on the hill, the model is making a ton of mistakes. Your altitude, your height, it corresponds directly to the amount of error.
So what's your goal when you're on this foggy hill? Well, it's to get to the very bottom, right? The lowest point in the entire valley. And that lowest point, that represents the minimum possible error. It's the sweet spot where our model is as accurate as it can possibly get.
Okay, so how do we actually get down the hill if we can pretty much only see our feet? We can connect this analogy directly to the step-by-step process that the gradient descent algorithm follows. It's all about taking small, calculated steps downhill.
So how does it do it? Well, it's a cycle. First, for step 1, the model starts with completely random values for its parameters. This is like being dropped onto a random spot on our hill. Then, for steps 2 and 3, it makes a prediction and calculates the error, which tells you how high up you are. Now, here comes the key part, steps 4 and 5. The algorithm figures out the gradient, which is really just a fancy term for the direction of the steepest path uphill, and then it just takes a small step in the exact opposite direction, downhill. And finally, step 6 is just to repeat this whole process over and over again. It takes another step, checks its height, and takes another, again and again, until it finally settles at the very bottom of the valley. Now, there's a really crucial question here. How big should those downhill steps be? This is controlled by a setting called the learning rate. And honestly, it's one of the most important settings you'll ever come across in machine learning. It basically dictates the speed and the success of the whole learning process.
You see, picking the right learning rate is a real balancing act. If your learning rate is too large, it's like taking these giant, clumsy leaps down the hill. You might completely overshoot the lowest point and land on the other side, which actually makes your error even worse. But on the other hand, if your learning rate is too small, it's kind of like taking tiny, super cautious baby steps. I mean, you'll get to the bottom eventually, but it could take a very, very long time. So finding that just right step size is absolutely key for efficient learning.
All right, let's just zoom out for a second. Now that we have a good feel for how this works, we can start to appreciate just how important gradient descent is to the entire field of machine learning.
So while we've been talking about the main idea, you should know there are a few different flavors of this algorithm. The main types you'll hear about are batch, stochastic, and mini-batch gradient descent. They mostly just differ in how much data they look at to calculate each downhill step, which creates a trade-off between accuracy and speed. We'll dive into these in a future explainer, but for now, just know they all share that exact same goal: find the bottom of the hill.
And its importance, well, it really can't be overstated. From the simple linear and logistic regression models we've talked about, all the way to incredibly complex neural networks and the huge models that are used in deep learning, pretty much every single one of them relies on some form of gradient descent to learn from data.
So here's the bottom line. Gradient descent is the engine that drives machine learning. It's this simple yet super elegant idea of just taking small steps in the right direction that allows a static algorithm to learn, to adapt, and to get better. It's the fundamental process that literally transforms raw data into knowledge. This was an introduction to gradient descent. In the next video, we will understand gradient descent mathematically and then implement it using Python. So be with us and subscribe for more such content.